Solving equations is what this video is going to talk about, and this is just part 1 of 4. So we've seen that you can solve complicated exponential equations by using logarithms. That was our last video, and that power property. Sometimes if we have a log equation, the base is not common or it's not a natural log, and so then we need some other way to be able to solve it, or put it into our calculator anyway. And that's when we can use a change of base formula. And that's this. Log base b of x can be equivalent to log of some new base to the argument x divided by the log of that same new base of the old base. So b is the old base, c is the new base, and take log base c of the inside, that's the x, divided by log base c of the old. So when it says inside, it really means inside the parentheses, because usually we have that argument in parentheses. So most often we're going to change to base 10 or base e, so we can evaluate it in our calculators. That means then that c, that new base, is going to be the common log, 10, which would then say we're going to take log base b of x to log x divided by log b, since it's base 10, or we're going to take it to the natural log, or the natural number e, so we take log base b of x to ln x divided by ln b. We have two problems here. Let's take one to the log and one to the natural log. So when we do this problem, we're going to first convert it, and then we'll take it to our calculator. So this is b is 3, and x is going to be 11. And I'm going to take it and let c be the common log, the common number. Okay, so the base is 10. So remember it said log base b of x was equal to the new log, which I'm just going to call log, of x, what's inside, which is the 11, divided by log of the base, the old base, which is 3. Notice my 10 is my c. That's why we don't have any subscript. And if we wanted to know a little bit better, to see the number that is, it would be the log of 11, close the parenthesis, divided by the log of 3, which is approximately 2.18. Now when we do this one, we're going to let b be 5, because that's a fact, and the x of the formula is 0.062. And then the c, this time we're going to let it be the base be e, or we're going to take the natural log. And just to remind ourselves, since we didn't say it earlier, it was log base b of x. And in this case over here, it's going to be the ln of the inside, which is x, divided by the natural log of the old base. So, ln, we have natural log, so ln of what's inside the parentheses, 0.062, divided by the natural log of the base, which is 5. So we need to solve this using either the exponent property or the graphing. And we've talked about change of base, but change of base is really only helpful if we have a log to begin with. And right now we're talking about only exponentials. We don't know how to do anything else with them but exponent property or graphing. So we have this exponential equation, and remember again that we always want to get the base by itself. So we have to peel away all the other layers of this onion. We have to get rid of that -4, which will give us 3 to the x equal to 6 plus 4, or 10. Now I can graph, or I can use the exponent property. And the exponent property is still new, so let's try solving it that way. We have 3 to the x, and we want to take the log of both sides, or the natural log. So we're either going to log or natural log both sides. And I learned to do it log all the time, but I'm going to just use natural log to be different for myself. So the natural log of 3 to the x is equal to the natural log of 10. And then the property says that the exponent, if it's in what's inside the parentheses, if it has an exponent, I can bring it out front. Actually, the x times the natural log of 3 is going to be equal to the natural log of 10. Divide that by the natural log of 3 so I can get x by itself, but then I have to do that on both sides. So as the exact answer, we have ln 10 divided by ln 3. So to solve this problem, again, we have to get to the base all by itself. That means that we have to divide the 5 off. Don't mistakenly think that's 20 to the x, because it's not. 4 is being raised to the x, and then I would multiply by 5. So I can't multiply 5 times 4. I have to divide the 5. So 4 to the x is equal to 3 over 5. And now I'm going to take the log property, and that means I have to take the log of both sides. And since I wrote log here, I'll go ahead and take the log of both sides. So log of 4 to the x is going to be equal to log of 3 over 5. And remember, we'd like to keep the fraction because we want the most exact answer we can get. The property says the x has to come out front, comes out of the exponent into the coefficient. So it's x times the log of 4 equal to the log of 3/5. And we divide off our log so we can get x all by itself. Divide the log here. Doesn't cancel on this side because it's not the same. So x is going to be equal to log of 3 over 5 divided by log of 4. And I'm going for an exact answer this time, so I'm going to say this is my answer. Alright, we've done log property. We're going to graph it. When I graph it, I can actually just leave the equation like it is. I'm not going to get an exact answer, but I'm going to get a pretty close approximation. But if I leave my equation just like it is, I come over here to my calculator, y equal 4 caret, and then don't forget to put this in parentheses since it's got terms in it, parenthesis x plus 2, close your exponent, and then minus 5, and then enter, so that the other side of my equation can be 6. Let's go to a standard window. If we can see enough of our graph, and it looks like we will. So we do second trace intersect, enter, enter, enter. Our little graph. My graph went something like this. And my graph goes something like this. This is y equals 6. And this tells me that x is approximately equal to negative 0.27. So here we are with our final problem, but we have a very involved looking exponent. But that doesn't make it any differently. If we want to take the property, then we can bring it down in front. If we want to graph it, we just graph what we see. Again, the property is more new than graphing. We've been doing a lot of graphing in our lives. So I'm going to do the property, and I'm going to take the log of both sides this time. So the log of 3x minus 1 is equal to the log of 17. And the property says bring the whole exponent to the front. So I have 3x minus 1 is 1 unit. That exponent works as one thing times the log of 2 now, because the exponent came out front, is equal to the log of 17. We want to divide off our log so that we can get that exponent. Even though it's in parentheses, we want that whole thing by itself, so we divide off the log. So we're left with 3x minus 1 equal to the log of 17 in parentheses divided by the log of 2. And I don't know if I've said this before, but please remember that this is the log of 17, which is a number, divided by the log of 2. This is not the log of 17 divided by 2. Those are not the same thing. It's the log of 17 divided by the log of 2. So now we come in here and we see that we need to add 1 because I got to get to x. That's what I'm trying to solve for. So I have 3x is equal to this nice big log. Log of 17 divided by the log of 2. And to that thing, I'm going to add 1. And if I want to get x by itself, I have to divide off the 3. So I'm going to say x is equal to, and this time, I'm going to take all of the log of 17 divided by the log of 2 and plus 1. All of that is going to be divided by 3. And if I were to put it into my calculator, I would have to put it in exactly like that.